So if this talk was next week, you could use my updated bio, which I'm not allowed to say like publicly or anything, but you're not public, you're friends, right?
Yeah, we won't say
I
anything.
need to say I was recently elected to the board of directors for the .NET Foundation.
You were?
Yeah. But no one on the internet's allowed to know that. I was told I'm under like an NDA or something. I don't know. So I have no idea what that means. I signed up for this thing, got elected, and yeah, I'll find out next week what it all entails. All right. Well, thank you all for hanging out. I am very glad to see in-person meetups coming back. So everyone who braved the thunderstorm that happened earlier, to come out here, whether metro traffic, all that good stuff. I greatly appreciate it. I know Lee greatly appreciates it. I miss this stuff. So I don't like virtual meetups. I think they're boring. I don't think there's anything personal to them. I like the in-person stuff. And I don't know, Lee said anything, you're all invited to go have drinks with us afterwards. Lee said he's buying all the drinks.
Wait.
Oh, I'm sorry. Just never mind. All right, usually I do this talk in front of a much larger audience, usually at a conference. Last time I did it was at NDC Oslo a couple of weeks ago. Much bigger room than this, a couple hundred people. So I use it as an opportunity to kind of talk about the logistics of a conference. When you go to a conference, there's keyboards that work. There we go. There's this fancy guy on the stage, far more handsome than I am. Maybe you can't even see his face. I'm here doing the work of giving you information, just being the shiny face. But all said and done, in the scheme of a conference, I do an hour's worth of work. And I think as attendees to conferences, we really don't appreciate the stuff that goes on behind the scenes. At Oslo in particular, there was a gentleman who was not just doing the camera, but he was also controlling the sound in the room. And there were people doing that in all the other rooms of the conference. There were folks manning all the food and beverage stations. There were the sponsors. There were the organizers passing out hoodies and shirts and all that good stuff. There were people picking up the trash. We really don't appreciate all the work that happens behind the scenes, but it's critical to the operation of the conference. And I use that as a way to basically say your application should work the exact same way. Not one of my applications, just a screenshot I stole from the internet. But let's imagine this is something I wrote, I have out in production. It's following kind of the same idea I just talked about. This is the fancy facade that you see as a customer coming to a site. You want to order some stuff, and I want to collect your payment information because I want your money. This is the guy on the stage, and we need to talk about all the stuff that needs to happen behind the scenes in order to make this deal happen in the best way possible. Let's walk through a workflow. Actually, let's walk through a workflow of doing it the wrong way. And I'm going to be, you didn't hear this from me. This is the application I came onto a very long time ago as a consultant, and we made some mistakes. So let's talk through the process. You hit Pay Now button. Welcome, come on in. And when you hit the Pay Now button, it would do a couple different steps. The first step is we would go create our order in the system, just so we could keep a reference for everything. We go check our inventory. We want a widget. We want something or another. We go check, make sure we have them in stock. We charge your credit card. Okay. We send you an email saying everything was good. And then we would come back with the confirmation and tell you, hey, everything's good. Going to get your stuff sooner or later. Now, I don't know if you all understand this, but email is not a perfect service. And we had a case where our SMTP server flaked out badly. So the user would get an error screen instead of the confirmation. But there's a small problem with the entire process. They would get the error, but we had already charged the credit card. And we had done all that work, and we didn't have a way to retroactively come back and clean all that up. That's a problem. And it's actually a really good introduction to the rest of this talk. So, hi everyone, I'm Kevin. I wasn't actually in the room when the formal introduction was done, but I'm a Microsoft MVP, independent consultant. I love building applications on .NET, deploying them in the Microsoft Azure, and I specifically love web development. So if you want to ask me any web app question you want to, I would love to have that discussion. Other than Blazor, I don't do a ton of Blazor, but that's just on me. I have some courses out there, and I'll gloss over these. I have one course on SignalR, SignalR Mastery, that talks about real-time web development. So if you're doing anything with WebSockets, or you want to have fallbacks to server sent events or long polling, there's a whole platform for that. More relevant to this talk, I recently released a course on HangFire, which is one of the things we'll talk about this evening. And that talks how to get set up and some basic use cases for it. But if you want, I'll put these back up at the end of the talk and make sure you all have access to them. But they're both on Udemy. So you can always go to Udemy, type in my name, and get the responses. So let's go back to our fire example. Everything's gone wrong. And I know you're all there going, why would you even write this code, Kevin? And to be fair, I didn't write the code. I just came in afterwards. So that's what a consultant does. We come in when everything's on fire and we fix the fires and we look good. But how should you fix this process? Well, let's think of it in a similar way that like Amazon works. Pretty sure you've all ordered from Amazon at least once in your life. If you haven't, good on you. But when you buy something on Amazon, you say pay now, it goes and creates your order. And then your order goes off and gives you a confirmation. Now, it's not a confirmation that your card's been charged. It's not a confirmation that your order is being, the inventory's been checked. It's not confirmation that anything's been shipped. It's just confirmation that we received your order. Then it's going to go off. It's going to do all the other work that's necessary to confirm your order. It's going to go through a workflow. And that's going to be the other stuff. Checking our inventory, charging the credit card, sending the final email saying everything's been shipped. We do this as a separate workflow because if something messes up, let's say email is not sending, we can just hold on that until the email server's back up and we can reattempt to send the email at a later time. Heck, we can even go back up the stack. If for some reason my credit card processor isn't working, which happens time to time, we could just pause, wait a couple hours, try the credit card again. We do most of our stuff on Stripe. There's been times where I've tried to charge a card on Stripe, it fails, but if I wait 3 hours, try the card again, works just fine. But that's all happening outside of the user. The user just presses the button, they get the confirmation. Everything else happens after the fact. So I use this as an opportunity to talk about the subject of background services. Doing work outside of what we see as users. And I really boil it down to two types of tasks. The first task is going to be on demand. These are things that need to happen now, but they don't need to happen in front of the user, some sort of workflow. Some examples might be sending those transactional emails. I need to send the email, but I only send the email in the line of code behind the pay now button. It can happen, needs to happen sooner than later, but doesn't need to happen at the moment I press the button. Payment processing, doing things like webhooks or notifying other services. All this work can be done in the background. Then we have scheduled or reoccurring tasks. These are things that are going to happen on some sort of schedule. I have a feature I just pushed the other day. At 6 p.m. every Friday, we're going to run a report and send an email to some stakeholders. All right, that's a reoccurring task, and it's going to happen at the exact time I need it to. We have other tasks that happen on some sort of interval, every hour, every day, every 6 months. A project that I used to work on a very long time ago, we actually worked solely on controlling the cadence of different work items based off hourly, daily, weekly, monthly, annually, biannually, you name it. Some things we do here, reports. I put in resource cleanup because one of the first project I'm on now, one of the first tasks we had to write in the background was cleaning up our blob storage in Azure. And this is before Azure had lifetimes or life cycles. I'm actually cleaning that stuff up. I started the project and we were putting stuff in blob storage. It was just a couple bytes of data every now and then. I'm like, all right, this is going to be future Kevin's problem to clean this up. And fast forward like 2 years, future Kevin went, I wonder how big that blob's actually gotten. Yeah, turns out it was 600 gigabytes worth of just random little text files we built that we weren't doing anything with. It was very temporary storage for a task. And I went, oh, we're actually spending significant money to store data that does nothing. So I wrote a very quick background task that would clean it up every week to make sure that we didn't accidentally run into that situation again. And we have since added other types of background tasks. So we have the two types of tasks. We have the on-demand things that you want to do, the triggered tasks, and then we also have the reoccurring or scheduled tasks. This talk spawned from a conversation, a workshop that we did a long time ago that was how do you deploy real production applications? And a lot of folks just don't understand the various ways to deploy a background service. And I can understand because there's not just one solution in the entire .NET stack. A lot of it depends on a couple of key considerations. First big one is where are you going to host your application or where's your service going to live? Some of us don't deploy web apps. Some of us might build something in Maui or have a app in the Windows Store or just some sort of installer on your local machine. Well, if you're doing those, you don't need a background service that runs in the cloud. You want something that runs locally. So you might want to build a Windows service that does some work in the background for you. And a lot of apps you probably use every day have a background service that's running and you might not be aware of it. If you're building a .NET application, you can run background services directly in the .NET app. And we'll show you a couple of ways you could do that. I assume everyone's building web apps nowadays. I do it all the time, so I just assume everyone does it. But if you're building a web app, there's various ways you can do background work in a web app. So ASP.NET Core, you can do background services or iHosted service. Because I deployed to Azure, I love Azure Platform as a Service for doing background work as well. Azure Functions, Azure Logic Apps. If you're on Amazon or Google Cloud, there are similar ways for you to do that work there as well. Other considerations for where and how you're going to build a background service is how resilient does the background service need to be? So let's use my email error as an example. What happens when there's a failure? Do you want the tasks to automatically restart itself and try again later? Do you want to allow it to fail and maybe just log it and ignore it because it's going to happen at a later time? And that's just at the task level. What happens if the service crashes? A Windows service. What happens if a Windows service crashes? We kind of expect the Windows service host to restart for you automatically. So a couple things you just need to be aware of. So that's what this talk is about, is basically, if I was sitting down and having a conversation with you and you asked me, Kevin, how do I build a background service in .NET? My answer is going to be, it depends, because that's what we all say as developers. No matter what the task is, what's how do you do something? It depends. And I've narrowed it down to a handful of tactics, as I like to call them, for building background services. And we're going to walk through all these various tactics and talk about the pros and cons of using them, why one might be better than another. And we're gradually going to build our way up from very local to very cloud. All right. And I don't have everything on this list. So if you want to come up to me afterwards at drinks and go, Kevin, you didn't put Coravell on this list. Well, Kevin didn't learn about Coravell until last month. So there's probably a very good reason it's not on the list. Let's start with .NET Hosted Services. I love this feature of .NET because it was introduced .NET Core 3.1. I might be wrong about that. But what's cool about .NET Hosted Services is they recognized that this problem existed. If I have a .NET application and I want to do some work in the background, how do you do that? I don't know how long you've all been developing in .NET, but remember, if you go back to like .NET Framework 4, let's give you a recent .NET Framework. You want to do some work in the background. That was actually a study in, well, you don't necessarily want to do it in your application host. You could spawn another thread. You have a background worker thread, but then you have to manage everything yourself. And it was just this cluster of complexity to do simple work in the background. And a lot of times the .NET team would just come back and say, well, yeah, you don't want to do that. You want to go put your background services somewhere else. But in .NET Core 3.1, is what we're going to go with, they introduced this concept of the .NET host. This is your application that's running. And your application can manage other mini applications or mini hosted services. So I could have a hosted service, and my application will start it automatically, and it'll just run for as long as it ever needs to run until the .NET host kills it or it kills itself. That's a bad term. I shouldn't say it that way. But hosted service ceases to exist when I tell it. But I can have a ton of these. I could have one for checking to run a report every Friday. I could have one that's listening on an Azure queue. I could have one that's listening to the file system. I could have one that's listening for login events from an event stream. I can have a hosted service for whatever I want. And they're usually very compact and they do one thing. Here's some sample code for a hosted service. So I'm using a slightly non-abstracted version of iHosted service called background service because it does a little bit of the heavy lifting for me. But if I create a class and call an implement background service, it's going to give me this fancy method called execute async. And it's going to give me a cancellation token, which is awesome. And as long as I'm in this loop and my application is doing work or it's just waiting or delaying, this service is going to be live. And let's say the .NET host says, we're shutting down, clean yourself up, and get out. Well, my cancellation token will get invoked. I can do my cleanup, and this will close down gracefully. But this hosted service is going to be managed by my .NET application, and I can do whatever I want to it. In this example, I'm going to check a folder, and every 15 seconds, for the demo, I knocked that down to, I think, 3 seconds. It's going to check the folder. If there's anything in the folder, we're going to delete it. Now, just creating the background service isn't enough. We have to tell .NET about it. That's done in our startup. Whether or not you do this in a startup CS file, or if you do it in the top level program main, whatever they call it, what you want to do is you want to go into your services. You want to add a hosted service and just tell .NET what service you're adding. When this host runs, .NET will automatically start it for you and do all the work. Now I want to start with a local implementation of iHosted service, and that's going to be building a Windows service. Has anyone in here ever built a Windows service not using iHosted service? By hand, the hard way. or top shelf? Top shelf? Quartz. Quartz? All right, so we'll talk about Quartz a little bit later. I love Quartz. Windows services pre.NET Core were a pain in the butt. There was a library called Top Shelf that made it much easier. But if you had to build a Windows service by hand, you had to know all the secrets of how Windows ran or installed a Windows service. And that was not well documented back in the early 2000s. Today, it is very easy. Just install a package. Well, I'm sorry, it's 2 steps. Install a package, extensions hosting Windows services, and you add the using statement. Use Windows service. Give it a name. You can set other criteria in here as well. But what's really nice about this is when or if you try to install this program as a Windows service, because of this one line of code, your application will do all the configuration for you automatically. Let's jump into a demo, because I like demos. All right, so this is some of my sample code. It's what I showed you in the slide, but it's fully decked out. And I'm not going to walk through every line of this, but essentially what we're doing is we're going to a folder, and we're checking that folder for files. If we see any files in there, we're going to delete the files. You can see up here at the top, it's implementing background service. That simply says, I'm going to get an execute async method. We can go into our program CS and see I'm adding the hosted service. So this is going to run whenever I start the application. So let's go to our app. I'll bump up the font a little bit more. We'll say .NET Run. There it goes. All right, so I'm checking a folder called ctemp, lack of a better name. So let's go to ctemp real fast. Now, zoom in. So there's nothing inside of ctemp. I want to add a new file. Just add a Word document. Zoom out. All right, so if we wait a minute for the service to check itself again, it's going to detect that there's a file in there. It's going to delete itself. Yeah, that's not worth clapping for. Oh my gosh, I told you not to clap about it. All right, that's not impressive. That's not impressive at all. I don't know why you clapped for that. What we want to do now is I'm going to clear my console. And I'm going to go copy some code real fast. We're going to build our application. So we're going to say .NET Publish, put it onto a directory. Cool, everything's there. I'm going to open up another command prompt as an administrator. For some reason, this doesn't work well in PowerShell, but no big deal. I'm going to go copy some more code. And there we go. I'm going to copy the publish path, which is this guy. I know y'all can't see any of this, so I'm going to zoom in. So this is called tactics.exe. Before I press enter, let me make sure I show you there's nothing under my hat. Scroll all the way down here. So it's going to be called tactics. There's nothing in here called tactics. Okay. Create service success. Let's go refresh our page. Scroll down. So I have tactic.windows service. I'm going to start it because I didn't tell it to start automatically. So the service is running behind the scenes. It's doing all the fancy work. We'll go back to our folder. And this time, instead of a Word doc, we'll do a rich text format because we're still using those. We'll wait a couple seconds. This is the problem with having the Windows service is I don't have the logging turned on, so I have no idea what it's doing behind the scenes. Hey, it's gone. Now you can clap. Yes. All right. But this was done with the same code base. I didn't make any changes to it other than adding the use Windows service. And it's working the exact way that I needed to. And it's all because of the power of iHosted service.
Question,
Yeah.
do those host agents or whatever you call those multiple boxes?
Yep.
Do those only work in a Windows service?
No, because what we'll do next is we'll take that exact same code, we'll move it to an ASP.NET 4 site.
Great.
And it's the exact same process. So,
That's similar to Jed's question online. He said he never heard about hosted services, but it sounds like it is supposed to run inside a nonstop web service rather than something like a cloud function, which I know we're going to get to shortly.
yep, exactly. All right, so some pros and cons of Windows services. The biggest pro is actually really easy to build. If we were having this conversation 10 years ago, I would have said, no, never build a Windows service. Now they're really easy to build. Windows manages the lifecycle for you. Back to resiliency. If your application crashes, your application, your coworker's applications, your stuff is great. Your coworker's application crashes, Windows will automatically restart it, do whatever it needs to do. Unless you have that disabled. The biggest con, you're limited to the single machine. So if you're deploying this, you're only deploying it to a single instance, a single server. So it's not meant to scale. One thing we didn't really talk about in that example is on demand. What if I have an exterior service that needs to send a message to my Windows service telling it to do something? All right, we're not having that conversation tonight, but that's a problem you would have to solve. You're also responsible for the resiliency of individual tasks. So let's say my service is running, but a certain task fails. How do I notify the logger? How do I restart it if I need to restart it? There's other issues I need to work with. One library I'll highly recommend is specifically for this problem, resiliency of individual tasks. If you've never played with Poly, Poly is a great library specifically for that issue because Poly will retry stuff for you automatically. It will rate limit things for you. It does all kinds of fancy resiliency tasks.
Poly as in
Poly wants a cracker. Yep, I think their mascot is a parrot. Yeah, I love Poly. If anyone's asking, Kevin.net is cross-platform now. Could I do the same thing on Linux? The answer is yes. You can use the systemd package, and I don't have the code sample in here, but where I would say use Windows service, you instead say use systemd does the same thing. So, yeah. So let's take our concept of iHosted service and let's move it to a different host. So instead of Windows service, let's move it to a web app. And this is what I do all the time. I take my hosted services. This is the one we built earlier. And I'm going to drop it into my web application. And it's going to do the exact same thing. I can tell you it's a web app because it's returning hello world. Same thing. Application runs, starts the hosted service for me automatically, does all the work, and it just goes forever until either the service returns gracefully or not gracefully, or the application fails or crashes for any reason. We'll do a demo of that now. I forgot to open all the stuff in VS Code. My apologies. All right, if I go over to cleanup temp folder, I don't know if it's 100% the exact same code. It's very similar though, but it's checking a folder, seeing if there are files in it, and it's deleting all the files if we find them. Every 15 seconds. But this time, because we're in a web app, I'm still adding add hosted service, pointing to the exact same class that I had before. It's just a web app instead of a Windows service or a console app. Let's run this one. What's my, all right, so this one uses a temp path. I did change the path name, just so you didn't think I was faking. And I'll stop the tactic service. So let's run this .NET run. Here we go. So this temp directory is in a slightly different location. We'll go out there real fast. Show you there is nothing in this folder. I want to add a new file. Do a publish file this time. And we're going to sit here and wait for service to run. All right, so it ran, found one file, delete the file. Awesome. Exact same code, different place, works exactly the same way. And this will keep running for as long as my application is running. Now, I showed you this in what? A Windows service, ASP.NET Core app. You can do the same thing on any Windows host or .NET host you're using. If you're building a Maui app, you should be able to do the same thing. What other types of Windows apps can we build?
WPF?
WPF, you should be able to do the same thing. Should. Haven't done it, so I can't tell you for sure. But anything on latest.NET has access to these classes, and you should be able to do all this work. Now, the thing to talk about with ASP.NET hosted services, pros and cons, also very easy to build. I like this because it runs inside your ASP.NET Core host. One way I use this specifically is I should really make a slide for this. We have our main web application. Our main web application is running hosted services in the background, and then we have other hosts. So we have some Azure Functions. We still have some stuff on HangFire that we'll talk about in a moment. And then we have some other exterior services. And what they do is they'll communicate to our web app via just a queue. We'll drop messages in the queue saying we're doing work or something happened. We use kind of like a glorified service bus. And our iHosted service just every couple seconds checks the queue. Do I have any messages? Do I have any messages? And if it does, takes the messages and then communicates to all of our web clients via SignalR, saying, hey, something happened. You need to know about it. We send out the notification. So that's one usage of running it inside ASP.NET Core that we do all the time. Yes, sir.
How are you passing messages?
From our services to our web app, we're using Azure Queues.
Oh, okay.
That's the way we're doing it right now. We've talked about using Service Bus, but everything's cheaper on just Azure storage. We've talked about using Redis PubSub. There's a lot of ways to solve that problem in particular. We're using queues just because it's cheap and easy.
What's the least dependency way?
Least dependency way. You set up webhooks in your web app and your exterior services talk directly to your web app. That would require no dependencies. I don't know if I would do that though. I don't know if I like that strategy. That might be a beer conversation because there's a lot of, well, it depends.
Jason online had a good question. He said, how does the hosted service share, or does the hosted service share the DI context?
Yes, sure does. If we go back to my sample, so we'll load this one. We go up here to the top, we'll see I'm injecting logger. So when this gets instantiated, I get my logger, but I can inject anything I want to. If I showed you one of our real apps, I'm injecting repositories and services and everything under the sun. If the background service needs access to it, I inject it here. That's a great question, Jason. Is that Jason F?
Yeah.
All right. Hey, Jason. Jason used to work with me on the particular project I keep referencing. So I think he's just patting me with questions he knows I know the answer to. At least I hope he is. Don't ask a hard question, Jason. Hosted services, I'm going to start on startup. Now, I might get a question later about iHosted service is, Kevin, can you control the startup and the shutdown of them from within your application? The answer is yes. It was a very long yes, because you have to implement some stuff that I don't know if I could do off the top of my head. But there's an entire orchestrator underneath the scenes for hosted services. So let's say you want to have a hosted service that only runs once an hour, shuts itself down, but it restarts later. We could actually write code that does that. The current examples I'm showing you do not do that. They just run forever. But I should really write a blog post about that, because I've gotten that question more than once.
I'm sorry to ask a dumb question. Didn't you show doing that with a cancellation token?
That's just for shutdown. What if you want to restart it again later?
Oh,
So like ASP.NET Core app, the only way I'm going to get that service to restart is to restart the entire apple, basically. So that entire service has to restart. And we don't want that. That's bad for everyone. And actually, the scenario I just talked about where we're checking the queues for messages, we had an issue with that service where our queue checker failed through an exception. We weren't catching it. It shut down the hosted service, and we didn't realize it because there was no notification, no logging for it. And we stopped getting messages to our front end. And it turns out as soon as we restarted the web app, it all started working again because it was checking the queue. And yeah, things you learn the hard way, right? All right, a good con for this. You are responsible for your own scheduling and stuff. So I kind of had a glorified timer just every couple of seconds doing a check, but that's not good for long-term things. So we're going to talk about Quartz for scheduling here in a moment as a good value add on top of hosted services or running Quartz by itself. And these are for the things that you need to do on a more strict schedule. At the top of every hour, every 15 minutes, every Friday at 3 o'clock. You don't necessarily want to do raw hosted services for those because they're just going to run forever, waiting and waiting and waiting to do the work until the certain times are met. It's not exactly high precision. All right. So next, let's talk about Quartz. Let's all talk about this problem of I want to be a little bit more strict with the timing of the work that I want to do. And I talk about Quartz because Quartz has been around for a while. If I'm remembering correctly, it's actually a port of the Java project over to .NET to do high precision timing in .NET. So for scheduling jobs and I'm going to be honest, I haven't used Quartz professionally in maybe 6 years. It's been a while. It was in the before times. So I'm kind of going based off of some of my previous knowledge of it, but it's been a while since I've used it in a working application. So here's a sample of Quartz. Same thing as before, you could use it with your injections. You're going to add Quartz and tell it, I want to set up a job. And a job is work that you want to have done. This might be cleaning up your folders. It might be checking your queues. It might be sending emails. It's the work that's going to occur at some point in time. And then you set up a trigger. So a trigger here is going to be a reoccurrence. So every 30 seconds, I want to do the work. But a trigger could be every Friday at 3 o'clock. A trigger could be on demand whenever I need to send an email. I could call a Quartz, issue a Quartz trigger. So we have two separate concepts here. There's the work to be done, and there's the thing that causes the work to be done or triggers the work to be done. Then we set up a Quartz server so that work can happen at a later time. But to do the work, we have to create a different type of class. So before we had iHosted service, here we have iJob. It's a similar concept. If I create an iJob, I have a big old execute method that goes and does the work. And this can just go do the work and then exit. It doesn't have to run forever. It will only run whenever the trigger is invoked at a later time. I put a couple of the The NuGet packages over here on the right, just because it took me more than 5 minutes to find them all, to remember how to do all this. The Quartz documentation could always use some love, but that's everything in general. Documentation could use love. Let's go do a demo. And it's a very similar demo. Open this in VS Code as well. Let's start in our program CS. And this is a web app, but I'm adding Quartz to it. You have to do an extra step to use .NET dependency injection in Quartz. That's fine. I have the line of code up there. But we're creating our job, which is the temp folder job. We're going to make sure only one runs at a time. And every 15 seconds, we're going to go do that work. The job had to change a little, though, just because it's a different implementation. We're using iJob. That's fine. Execute. And the work in here is very similar. So we're going off, looking in a directory. If there are any files, we're going to delete the files. I don't remember what the folder is, so let's find out. .NET run. All right, there's a little bit more logging here. Let's see, I should have a path that I'm checking.
Third from the bottom.
Third from the bottom. Oh, I see it. Thank you, sir. All right. Oh, it's the same one as before. Okay. So clean up temp folder service. That's not it. All right. Again, there's nothing in here. We'll go add a new file. Let's do Excel this time. I learned the one that you're not supposed to add is access, because access doesn't actually create the new access file. You know what it does? It opens access. Like, who in their right mind wants to open access?
Have access.
I've run across 2 jobs in the last year.
During my ranting, it deleted the file, so yay, it did the work for me. But what's really cool about this, and what I appreciate about this process, is the job is separate from the trigger doing the work. So if I don't want this job to run every 15 seconds, maybe I want it to run every day, once a day. But I could also have another trigger that is user facing. Maybe I have an endpoint where if the user goes to it, it manually calls the cleanup folder job and goes and does that work. If this is a job that I want to scale out, maybe I have multiple servers that are all going to have the same Quartz tasks, I could actually have the job only run on one particular server at a time. I can have Quartz track when the job last run. So it could talk to say like a SQL Server database and track the last time work was done. If this is the task that is required, that needs to complete with success, and if it doesn't, I can tell it to try again automatically later if it doesn't succeed. Quartz gives you a lot more options, far more options than we have with just iHosted service. The drawback, though, and this takes us into our pros and cons. Because precise scheduling and timing, I can do the work whenever I need to do the work, precisely when I need to do it, whether that's on demand or on some sort of interval. I now have the option for one-off jobs. If I only want to do the cleanup when someone presses a big shiny button, I can do that. There's a concept of the job server. So maybe I don't want my web app doing that cleanup work. Maybe I want to have a separate service that's running all these jobs. And my web app can issue jobs to the job server. Now, I didn't show you an example of doing that, but I could do that if I wanted to. The biggest con, I think it locks you in the Quartz. I think we all have different opinions of vendor lock-in. If you hit a point today where you're like, Quartz is great, but then 2 or 3 years from now, you realize I don't want to use Quartz anymore. I want to use it a different mechanism, you'd have to rewrite most of your jobs because the existing stuff you have is locked into Quartz. Or maybe, hopefully you're abstracting out the work. So Quartz is just the mechanism for calling another service that does the real work. So you don't have to completely rewrite everything. But I don't like this concept of locking into a platform that's not just .NET. And actually, we'll talk about this a little bit more here in a moment when we get into HangFire, because I have that exact same scenario. It was also a pain in the butt to figure out how to tie into dependency injection for .NET. Ended up being one line of code, but it was one line of code that took me 20 minutes to write because of documentation. Well, let's move on to another tactic. This one I use quite a bit, and that's HangFire. What I love about HangFire, the number one feature, I think, whenever I show it to someone is HangFire can have a UI, a user interface, a way for you to graphically see in production that work is being done when you expect it to be done. So this is a sample of the HangFire dashboard. A couple things you can see here. I have jobs that are running. If a job fails, I can see jobs that need to retry later. I can have jobs that happen on some sort of interval, recurrence. I can also have multiple instances of HangFire. So if I don't want just one instance of HangFire doing all the work, I can have multiple and they all share the responsibility. My favorite part of HangFire, not even is really the UI, it's that I can just use my own code. This is a sample class. That's just a sample class. There's nothing on here that identifies it as a HangFire class because HangFire doesn't care. HangFire, the whole position is, you tell me what objects to instantiate, and you tell me what methods I need to go execute, and it will go figure all that out at runtime. So this simple class has two methods on it, execute and generate. But I could call it Kevin and Lee. I could call it yin and yang. The name of the methods, the name of the class do not matter. And there's no implementations. Now this is a little bit heavy, so we'll walk through it. Setting up HangFire, it's built, it's .NET native. Add HangFire. You have to tell it where to store its metadata. You can't use it by itself. You have to point it to something. SQL Server is the most common, the free choice. If you want to pay for the license, you could point it to a Redis server, which is great. There are also third-party community plugins that will let you point to other types of databases. But basically, if you have any ADO-supported database, you can point HangFire to it directly. And what this is going to go do is connect to your database, create 5 or 6 tables, and it's going to manage all of its workload for you in that SQL Server. Now, there's 2 types of jobs. There's reoccurring jobs. Actually, there's 3. So there's reoccurring jobs, and these are jobs that are going to happen on some sort of interval, like we've been doing. So every 30 seconds, I'm telling HangFire, I want to go create an instance of my cleanup temp folder job, and it's a generic. Yay, this is what I love about it. I can just tell it, go run execute, and I'm telling it how often to do that work. So CRON every 30 seconds, it goes and runs that method every 30 seconds. Now, because it's a generic, I can pass parameters into that. I can pass integers, I can pass strings, I can pass complex objects. HangFire is going to convert all that into JSON behind the scenes. So it'll serialize all your parameters down to JSON, and it will track those parameters over time. So you can pass whatever you want to into your code, and HangFire is going to just manage it for you. As a reoccurrence, then we have work that's done in the background, so the on-demand triggers. And there's 2 ways to do it. One is called NQ, which I don't have the sample of here, but the other way is schedule. So I want to go do the same thing. Call a method later in 30 seconds. And because it's generic, tell it what class I want to create and what method on the class I want to execute. And then I add the dashboard. Now this makes more sense in the demo. We'll jump into the demo. Open up VS Code again. All right, I did something slightly different in this demo. You see I'm configuring HangFire. Let's get rid of that sidebar. Connecting to my SQL server, which is already running. And you know what? I didn't show you this. I forgot to do the cleanup. I was going to delete all the tables and stuff, but you know what? We're just going to leave that stuff. Let's go down here to the bottom. Let's see. I have my recurring job, so every 30 seconds, go clean up our temp folder. But instead of me going and creating the files manually, I added a method or two to go generate those files for me automatically. So not only will I create the files through the app, but also clean them up through the app. And I have two samples here. Generate now just goes and does the work as soon as possible in queue. Schedule, generate later, will go do it in a certain amount of time. So I can just say, do this in 15 seconds. I can say do it in 3 days. The time span doesn't matter. You can pass in whatever you want to. And HangFire will just watch and wait for the given amount of time to pass before it goes and executes the method. All right, I'm not going to delete the tables, but I'll show you the tables. How about this? So let's come in here. So these are all the HangFire tables. Manages all for you. It's in its own schema. So if you are worried about database security and all that, you can protect all your other schemas as you normally would. HangFire, you can protect separately if you need to, but it's all separate. Let's run our .NET code. All right, a couple things happening here. Let's go find my, here's my URL. Always get lost in the halls. So let's open our page, hello world. That doesn't mean much to you. Let's go to HangFire/HangFire. This is our HangFire dashboard. You see it's just ticking away. It's waiting for work to be done. I can show you work that's been done previously because I didn't kill the database. You can see all of our completed work. These are my jobs that are running in the background. We see it ran a few seconds ago, All these jobs have data. What class was created? What method was executed? It tells me all that up here in the top. I have a full state tree of what happened. So the job was created, the job was in queue for later, it was processed, what server processed it, did it succeed or fail. I also have options to delete the job, or I can re-queue it. Maybe I want to repeat this job at a later time. I can just add another copy of it back to the queue. Now let me come up here. Where is my, let's go into my temp job. All right, so this would be the temp folder, which I think is the same as before. All right, I think it is. So let's go to my endpoint generate now. What generate now should do is generate a whole bunch of files in here all at once. Generate now. Now I actually have a timing issue sometimes where I generate the files so fast, they get deleted as fast as I create them. which is what happened here. Oh, it's in slightly different. All right, I'm going to do that again because we all failed to see it. All right, there are all my files. And so generate finished. We'll wait a couple seconds. The job will run again. And they're all gone. I can go into HangFire and see there's my generate. And it took a couple seconds to run, no big deal. But it all worked. What was my other one? Generate later. We can go into HangFire and see I have a job scheduled for later. Let's go off in a couple seconds, but it's just going to stay here in queued. And it ran. I refresh. Oh, wrong job. So it should be queue and queue. Right. Yep, it ran. There's all the files that got generated. And then here in a couple more seconds, it is going to clean it up. Yep, they're all done. Let's close this and let's add an error, because that's the thing that happens sometimes. So let's go into generate now, and I'm going to tell it to, going to generate. We're going to throw a new exception. Just say no. .NET run. Refresh. Now I'm going to go back to generate now. And I'm going to scroll down. We'll see that we created the job. We tried to process the job, but it failed through an exception. I'm going to get my call stack of where it failed. So if I was a couple layers deep in the call, I'd have a full call stack. I have the exception that was thrown, but best, HangFire said, well, it might just be a fluke. It's going to reattempt the job in a couple seconds. And without you changing any defaults, it'll try up to 10 times before it eventually just fails. And it'll keep waiting a tad longer in between every retry. Eventually, when it fails, it's going to end up in a failed state, and we could go look at the entire call stack for everything. Last thing I want to show you, just because this is another really cool feature of HangFire. Let's say generate takes a string, and we'll call it prefix for the file. And then for all the file names, we'll prefix the file name. Well, you see now I have build errors because generate is missing a parameter. So we'll call this one now. And we'll call the other one later, passing in the strings. We say .NET run. Go into our generate now, refresh. A few seconds ago. So here we try to call generate. It told me the parameter now. String is a simple variable, but if I was passing in a more complex object, it would show me JSON of all the data I was passing in. We've used this numerous times to just figure out errors in some of our code. We'll have something that runs overnight. It'll fail. We'll go back and look at the parameters that were passed in, realize there was an issue with the data. We can repeat the call in our development environment, cause the same issue, fix the issue, deploy the fix. Even better, after we deploy the fix, we can go back into the failed call, re-queue it, it runs successfully after the fact. And I love this little feature. Now you do run into a case where we go in here to schedule, see where it says cannot find the target method. The reason for that is because I've changed the signature of the generate method between calls. This is a drawback to HangFire. Whenever if you change the signature of any of the calls that you're making in the background, HangFire doesn't know that this has changed. There's no way to tell HangFire that it's changed that I'm aware of. So you just run into these cases where your logs might be off of it because HangFire doesn't know how to correlate this generate to my new version of generate. And lastly, so I have recurring jobs. This is the job that's running every 30 seconds. I can run this as often as I want to, just trigger it. You already know what it does in the scenes. I can have multiple job servers. We run HangFire on every web app. So every instance of the web app will show up here. We also do dedicated job runners. So we have services that all they do is process background jobs. They show up in this list as well. And it's nice to just have a visual, a UI for all this work, where everything else is in logs. So hosted service, you have to rely on logs. ASP.NET hosted services, you have to rely on logs. Quartz, you have to rely on logs or standard output. HangFire is just nice because it's all right here in UI. And sometimes we will have an issue. Someone will say, hey, I didn't get the report, or I'm getting error on the front end. We'll go check HangFire, and our HangFire service might have slipped up and might need a restart. So it's nice to have the heartbeat last time the service was seen. But all that said,
So question, so HangFire is designed to be like some central location on your network
that's right.
where you can go.
They-
And then
they
it
all-
deploys little
Talk to
clients.
back in SQL database or Redis or whatever you want. But you have to have that. You have to have that backstory for everything to go into, which is a downside, which I'll talk about. The biggest pro is you get the precise timing and scheduling. You can do on-demand work. That works great. I love scheduling one-off jobs when you need the work to be done. It's easy to call HangFire, tell it to go do the work. It happens. I love strongly typed jobs. I get to bring my own code, and I just tell HangFire to use my code. I don't have to implement iHosted service. I don't have to implement iJob, just whatever I want to write. Made it really easy for us in one example where we moved off of HangFire. We moved from HangFire to Azure Functions, and we didn't have to rewrite any of our code. We just took our code from HangFire over to Azure Functions, and it worked perfectly. It is nice having the UI. That is one of my favorite features, is just having that dashboard turned on. You can turn on authentication for it. So if you want only administrators or certain users to have access to it, it's like 3 lines of code to turn on authorization. We do that. But the biggest con is you have to have that backend data store, and it's SQL Server by default. There was a problem with HangFire a couple years ago where you could accidentally DDoS your SQL Server with HangFire. Ask me how I figured that out the hard way. I was on Azure SQL, and we went live with HangFire, and all of a sudden our web app stopped responding, started getting timeouts. It's because HangFire was pulling the SQL Server too often. And so fix that issue. The solution for us was actually just have a dedicated SQL Server for HangFire. It was easy enough to do. The better data stores are paywalled, which is Redis. So ideally, you would want to use Redis or Service Bus or something behind the scenes. Those are paywalled, which makes sense because they're much better solutions. I talked about having a separate job server, which is ideal in all these situations. You don't want to ever do this work in the same, basically, app service as your web app. You want some other service doing it. Setting it up to do that work with HangFire is actually a pain in the butt for a variety of reasons, but I don't have time for that right now. We'll talk about that over beer. I do have a course on HangFire. You should totally go buy it. It's really cheap. It's only 129 kroner because I did this talk in Oslo, and that's how much it was in Oslo. But let's move on to my last tactic for the evening, and that's Azure Functions. Usually I gloss over this in a conference environment, but because we put all of our applications into Azure, it made a lot of sense for us to really leverage different platform services of Azure instead of making our apps do a lot of the work. And the reason is cloud scale. My application will scale as much as I want it to within its app service plan. But I was working on a project. I can't even tell you what the project was. It was years and years ago. And someone said, Kevin, have you looked at doing serverless? And I used to be in this camp, and you tell me if you're in this camp, where I was like, serverless, that's just someone else's servers. There's still a server there. It's not serverless. It's just someone else's servers. And I had a task where I needed to process like millions and millions of entities. And we had all these entities, and the classic .NET developer C# guy, I'm like, okay, well, let me for each through this. Okay, that's too slow. So let me use the parallel task library. Let me use more threads. Let me just crank through this data. And now it's slow. So we built a proof of concept where we built an Azure function to do the processing of one entity. And then we loaded a queue with all the work that we had done. And Azure Functions, if you've never used it before, does this really cool thing where if you're watching a queue, Azure Function says, well, there's still work to be done in the queue and you're not done yet. So I'm going to give you more instances to go do the work. And it keeps giving you more and more instances to do the work until if you don't set the limit, it's going to go. It's going to create what, like 120 instances on certain plans. What accidentally happened, we cranked through all in like minutes instead of originally it was hours worth of work, just letting the computer process it. So I became a believer in Azure Functions like overnight because of that sample. I do a talk specifically on Azure Functions on annihilating workloads, and we do that where we have a local example of doing complex work that we can't actually complete during the talk because it takes too long. Put that same workload into Azure Functions and it's done in 30 seconds. One of the coolest demos I do. I don't have time to do it for y'all. Sorry. You get the timer example. Azure Functions works from this concept of triggers and work. So actually not that all off what we've been talking about up to this point. In Azure, I can say, I need to do work every 30 seconds. And I have a class, I have a method. I have to decorate a method with a name. It has to be a unique name. But I tell these methods that they're a particular type of trigger and whatever attributes that trigger requires. This is timer trigger. Every 30 seconds, I'm going to go do some work. Every 30 seconds, I'm going to go do some work. And the Azure host, the Azure Functions host, is going to manage this work being done every 30 seconds. So I get that resiliency. If this timer fails, it can try again. It can come back and try to catch up to where it was. I get full dependency injection either in the method itself or I can have a constructor. But it's the same concept that we've been talking about previously, just a slightly different context. The nice thing about Azure Functions is there are a lot of different types of triggers. This, I don't even believe is the exhaustive list. This is just a couple of concepts. But if I want to execute an Azure function every time there's a message on service bus, I can do that. If I want to, I wish Swinburne was here. Well, he's not with Twilio anymore, so it doesn't matter. There are Twilio triggers, so maybe I get an SMS coming in or a phone call. I get to execute an Azure function. My favorite SignalR, if I get an Azure or SignalR message coming in, I can handle that. My favorites are queues. I use queues a ton because they're cheap, fast, and really simple. So we'll monitor a queue. But then you also have like webhooks. If a request is coming in via HTTP, maybe you need to go handle it immediately. So no matter what the trigger, you can go off and do the work. Now, what demo did I write for Azure Functions? I don't actually remember. Every time I do this live, I've always had to stop at this point because time. So you're the first ones to see this demo in a year. Oh, I remember this demo. Okay. So it's not the folder cleanup because that doesn't work well inside of an Azure function. Well, what this is going to do is every 30 seconds, it's going to go out to my website and you're not looking at the slides. Sorry. There we go. You can see what I see now. So every 30 seconds, we're going to go out to my website, pull my RSS feed, and we're going to write my RSS feed to blob storage. Simple enough. If I come in here, I'm going to say bunk run. That's it. I always forget this part. Func start. Okay. All right, so this is off and running and can't really see anything because it hasn't happened yet. But I have a timer and we're just waiting for that timer to execute and it's every 30 seconds. We open, I don't want to go to Edge, I want to go to Storage Explorer. So Storage Explorer, we can see through the logs, the timer executed. It went off to my site, got the RSS feed, and it dropped the RSS feed into my output folder, which is right here. So there we go. We can see last modified, 803. Oh my gosh, it's getting late. So there's my file. If I delete it, it'll just recreate itself in a moment. So delete. Of course, it's taking this time. Oh, 804, create another one. Yay. Every 30 seconds. But this is just going to run continuously forever until, actually, the only way to get rid of it is you go into the portal, disable it, or you redeploy it without the timer. So I have this timer for the end of time. We do all of our reports this way now. So we have a variety of triggers that execute on whatever cadence they have to run. And we go pull data, create the reports, and the report to who it needs to go to. Now this handles the case of reoccurrence, whatever interval we want to use. Actually, I really wish Wimberger was here because he wrote a really cool tool called in CRON tab. I don't remember, but basically it helps you build the CRON syntax for Azure Functions specifically, which is different than regular CRON syntax. It's close enough, but there's like this 5% that's different. He wrote a really cool tool to help you figure out what your CRON syntax should be. So I wish he was here. But this will just go indefinitely. If you need to do triggered calls, you could do simple webhooks, which I don't have an example of, but you're not limited to just intervals, scheduled jobs, or on-demand jobs. You could have timer or triggers for a variety of different things. Even better, you can write your own triggers. So if you have a certain case in your application or your domain that would make sense for an Azure function, you can create your own trigger. And like we've looked into that in a couple of cases. We never moved forward with it, but it's all adaptable to your needs. So to recap, this demo, pros and cons of Azure Functions. Biggest pro is very precise scheduling and timing. Our jobs run on the second we need them to, guaranteed. I have a lot of options for triggers that aren't just the timers or the webhooks, but I could talk to blob storage, or I could talk to queues, I can talk to service bus. sky's the limit. Actually, they just released a bunch of new triggers for SQL Server that I haven't played with. So if you wanted to run an Azure function whenever a row is updated in a table, there's a function for that, or a trigger for that. I'm a huge fan of cloud scale. If I need to do a lot of work very quickly and I don't want it to cost a lot of money, Azure Functions is a great solution for that. All the tasks are independently resilient. So it depends on the trigger, but if my timer were to crash, it would retry itself again at a later time. If I have queues, they'll automatically retry themselves up to a point. Things like HTTP triggers, if those fail, they just fail. They return an error to whoever's calling them. But what's really nice is all the tasks are separate. So if you have a failure, you can go look at a particular function and see where it failed by. Biggest con, obviously, is Azure for Azure Functions. I talk about Azure because I love Azure and because we're in a Microsoft building, and I'm a Microsoft employee. That's not the sole reason I talk about Azure. But if I was on AWS, Lambda does a lot of the similar things, just different. Cloud, Google Cloud, I don't know. They won't actually use Google Cloud. That's not federal. I don't know, but Azure. But all that said, the biggest conclusion of all should be, if you're not doing a lot of this work in the background, if you're doing it after someone presses a button, you're probably doing it the wrong way. There are a lot of different ways to do background services. I'm just touching the surface of how I've done it in different applications. This isn't all inclusive. And if you want to go out for drinks afterwards, we can talk about other ways to do it, but that's really boring. We should talk about other things. But thank you all for hanging out with me. Thank you for coming here in person. I appreciate it so much. And thank you, Lee, for inviting me. Very glad to be here. And thank you all so much. Norwegian for thanks. So you can tell how much prep I did for this. I didn't change any of my Norwegian slides for this. Oh,
Know your audience.
know my audience. Lee, do we have any questions? Well, do we have questions in here? Do we have questions from the chat?
Yeah, Jed has had a couple questions.
Sure.
He wanted to double check if the dashboard was free for HangFire.
Yes. Yep. That comes out of the box.
Everything you showed was free.
Yep. Everything was free. I don't like paying for stuff either, so I try to show everybody it's free. Jed, you had a question.
Yeah, so I was just gonna say that I had a lot of questions queued up, but every time I had a question, you always answered it.
I answered it.
later.
Oh,
Yes,
do
it's
my
very
best.
good. So thank you for the session. Yeah, I'll just add with a fun fact instead. We were at IKEA earlier, and there's one of those signs that says "tech." This means thanks in
Yeah.
Swedish. So I guess it's the same word. So I learned the same word twice.
My stuff is just as much as simply as a IKEA furniture. So. All right, what do you got, Lee? I see him pop up on the screen there, but I can't read them quick enough.
Jed had a comment that could have been a question if you squinted at it funny. He said he's terrified of running up an Azure bill using Azure Functions. Do you have any comments, thoughts, or concerns?
I could say that about a lot of Azure services,
Yeah.
not Azure Functions. So the demo I do, annihilating workloads, I can process several million entities in a couple seconds. It costs me less than a cent to run that workload. Our heavy lifting Azure Functions bill less than $30 a month. And a lot of those are continuously running. So you could rack up a bill in Azure Functions, but you have to really try to rack up a bill in Azure